Hey guys, welcome to Science Today. I came back to the school so that I could do this lesson because I felt like I had more stuff here to work with, and it's cooler wearing a lab jacket making a YouTube video than sitting at a desk. So today we're going to talk about solubility and concentration. Shouldn't take too long, but I want you to watch. It's stuff that you probably already have seen before in your own life, but we're just going to do it right now. So the first thing that you have to know in this particular unit are two words that are going to follow you forever in science. And those two words are number one, solvent, and number two, solute. Super important words for you to understand. A solvent with a V has to do with liquid or water that you're dissolving things into. So that's what the word solvent means. It could be even this oil is a solvent because I can put stuff in it. Anything that's liquid is called a solvent. Then the second word that we're going to talk about is the word solute. And solute is powder or things that you try to dissolve, like this juice powder. This is a solute. It's something that you put inside of a solvent, like water, and you mix it all together. Solute, solvent. Solute, solvent. Cool. You've got to know that powder is the ute and solvent is always a liquid. Awesome. So the next thing we're going to talk about is how to measure concentration. And really what that means is, are you going to be drinking church juice that's disgusting and super dilute and doesn't taste very sweet? Maybe that's like my mom's juice that she makes at my house. Or is your juice going to be like my juice and it's going to be legit, like a BAM, like supersonic, lovely flavors? So concentration is really, it just tells you the amount of solute, remember that's the powder that you put inside of a solvent. So basically how many grams of this are you putting into the water? You can do a calculation and figure out how concentrated something is by watching the video right now.
All right, so this is concentration, you guys. So just to make sure, concentration of a solution tells you the amount of solute, so that powder that gets dissolved in a specific amount of solvent, which is usually water. So basically what we're looking for is grams divided by milliliters. So you're looking for grams, which is like weight, which is like powder, and you're dividing it by milliliters, which is like liquid. So if we look at this example right here, it says 50 grams of solute, so that's powder, is dissolved in 100 milliliters of water, so that's liquid, and has a concentration of 50 grams over 100 milliliters. 50 grams per 100 milliliters. What is the concentration of 20 grams of hot chocolate dissolved in 100 milliliters of water? So really, guys, all you've got to do is write concentration is the grams, so the mass divided by volume. So what we do is we take the grams number, 20 grams, and divide it by the amount of liquid, which is 100 milliliters, and we get our answer. And so this could be our answer right here, 20 grams over 100 milliliters. Or if we divide that on our calculator, it would give us 0.2 grams per milliliter. So you see that the units here are G over ml, and that's just because we used both of those things in our equation and we never canceled them out. So all you're doing is dividing the top number, which is grams, divided by the bottom number, which is usually milliliters or liters, and that's how you get concentration. Now we have a grade 8 math question. What is the percent of this? So just remember, taking into account if you got a decimal here, you always want to, if you're going to turn into a percent, that's a percent and it's out of 100, right? And so all you got to do is multiply that 0.2 by 100 to get the percent. And you actually get a concentration of 20%. 0.2, which was right here, times 100 to get the percentage. Make sure that when you compare concentrations, you have an equal amount of solvent, the number on the bottom, or the fraction. So if you're doing a comparison like this one right here, 10 grams over 50 milliliters or 25 grams over 100 milliliters, and I want to know which one's more concentrated, there's a few ways we could do this. The first way is making the bottoms the same. And so what I'm just going to write up here is if we have 10 over 50 and we want to know which one is bigger, which one is more concentrated. So what we would do is we would want to make the bottoms the same. So I would want to make this 50 into 100. If I did that, I would multiply the bottom by 2 to get 100 here, which means that whatever I do to the bottom, I have to do to the top. So I'd times the 10 by 2 and I'd get 20 over 100. Now you can compare both of these and see which one is more concentrated, the first one or the second one. We notice that 25 over 100 is a bigger number, so this is actually more concentrated. Another way that you could figure out which one is more concentrated is literally just to divide the top number by the bottom number. When you divide 10 divided by 50, which is right here, you get 0.5. And when you go 25 divided by 100, oh, sorry, hang on. Let me just make sure this is right. 10 divided by 50, you get 0.2. My bad. Hang on. 10 divided by 50 is 0.2. So let me just write that right here, 0.2. 25 divided by 100 is, 25 divided by 100 is 0.25. So again, you notice that this one is actually bigger than this number. So this one is more concentrated. It means that it would have more juice particles. It means that it would just taste more like Duz's juice and not like my mom's. So that's how you figure out which solution is more concentrated. I'm just going to do the last one here. And so we could do it two different ways. 37 over 100, and then we have 16 over 25. It looks like we would want to make this 25 into 100 just to do a comparison, because then both of them could be 100. The bottoms could be 100 here. And so because I times by 4 to get that, I would need to go 16 times 4 to get that, and it's 64. Oh, so definitely this one is much more concentrated. The other way that you could do it is just divide 37 by 100 in this particular case right here. And your answer would be 0.37. And you could just do 16 divided by 25 right here. And you get 0.64. And again, you notice that that one's more concentrated. So that's how you figure out concentration.
So here's the thing, guys. When we put some of this juice powder, which is a solute, into the water, which is a solvent, we make a solution that's concentrated. We don't know how concentrated it's going to be, but what we can do is we can stir it to make it into a solution. We can make it into some Kool-Aid. Theoretically, this Kool-Aid wouldn't taste very good because it's a big and a large amount of water. In fact, it's over 500 milliliters of water that I've used here. If I use 20 grams only of this solute inside of my liquid, I can figure out how concentrated it is. And I'm going to tell you right now, I like things with big concentrations. So here's the deal. The next step that we need to talk about are the words saturated and unsaturated. And here's all you got to know. Duz likes saturated things because it's full of sugar. We're talking like saturated is when you put as much of this stuff into here as you can get. The deal is that it needs to dissolve. Otherwise, you make a different type of solution. So literally what I'm trying to do is mathematically fit as much powder as I can into this liquid. Oh yeah, for it to taste, oh yeah, baby, super great. I've got to stir it until it all dissolves. And so saturated solutions have tons of solute, tons of powder inside of this beautiful liquid. It tastes really strong. So that's what the word saturated means. And the other thing is that we have to take into account the temperature of this water. Something that you need to know is if you want to make really, really concentrated juice, secretly, without your mom knowing, is heat up a bunch of water. Take this water, put it into a beautiful cup, just like this. The deal is that the particles are moving faster in this water than they are moving in my cold water. So actually, you can fit more juice inside of this hot water than you can inside of the cold water. That's what I call saturated. Unsaturated is usually, another word that we use for that is the word dilute. When something is dilute, it's not very exciting. In fact, it's pretty like gross juice if we're gonna talk. So we still are gonna use the same amount of liquid. So if I was using a cup of liquid, but unsaturated solutions have room for more powder, room for more solvent. So it kind of looks like this. So your mom, she doesn't like using tons of sugar, so she makes you something called an unsaturated or dilute solution. We didn't put very many grams of this. Check the difference. Okay? what type of juice are you gonna drink? I'm choosing this one, baby. I like saturated, sugary drinks. I don't like that looking like it tastes like something, but then you drink it, it just tastes like lukewarm, gross, semi-flavored water. So here's the deal. Solubility is the maximum amount of solvent that you can actually add into a liquid, into sort of a fixed volume of liquid at the same temperature, and all of it dissolves. That's what solubility means. Once we get saturated, we're really putting as much maximum as we can. The saturation point is when no more solute can fit. And in fact, it looks like we've reached the saturation point here. I'm going to come nice and close with the camera so that you can see. But if you look really closely here, you're going to see that there's actually a ring of powder that's at the bottom of this beautiful liquid. The deal is that we've reached the saturation point. No more of this liquid can get fit into the water. And so that's its saturation point. It can't get saturated anymore. There's three main things that affect solubility, and you need to know what they are. And those are the type of solvent. So what type of liquid are you using to dissolve stuff? Water is the universal solvent. What that means is that everybody uses water to dissolve stuff. But that's not the only thing that can dissolve stuff. Things like oil can dissolve stuff too, but actually it's a pretty bad solvent. So the type of solvent that you use actually affects how much stuff can dissolve. We look at the type of solute that you're using. So things like salt, that's a solute, and we use salt all the time. So this is the type of, and salt actually dissolves pretty easily in water. And you know that because you've seen it. Okay, I can stir this in here no problem, and it'll go away. But if you try to actually get baking soda into water, you're gonna see something totally different. Here's what's interesting about this type of solute. Baking soda actually doesn't dissolve well in water. So if you're a baker, you'll find it interesting to know that I could stir this for probably about 5 minutes and I would still see particles in it. It doesn't like to dissolve with the water, so it doesn't dissolve well. Whereas if I was to put salt into this cup of water right here, we know that it would go away really quite quickly because salt actually dissolves really quickly. So the type of solute makes a difference, and the type of solvent makes a difference. And the last thing that we want to talk about today is the temperature. And obviously temperature is going to affect how much something dissolves. The other thing that affects stuff is the size of particles, which I put some big salt in here, so I need to kind of stir it to get it going. But you'll notice here that look at the baking soda. It actually doesn't like to dissolve in water. An interesting fact for those of you that like interesting facts. The last thing that we're going to do is how temperature affects water, and I'll show you that in a second. So the last factor affecting solubility is temperature. And temperature makes sense because we know that when something gets hot, the particles move a ton faster. When we actually can demonstrate it this way by having this beautiful, nice hot water that we're going to pour right here into the flask. Here we go. So here's the deal. I want to demonstrate how much faster that water is moving by using this blue food coloring. So what's going to happen is I'm going to put 1 drop into this particular hot water, and I'm going to put 1 drop into the cold water. Holding it up, I just want to show you how much faster the particles are spreading out in the hot one as opposed to the cold one. Look at how much faster that particles in the blue food dye have dispersed through the hot as opposed to the cold water. You can see that it still is diffusing, but it doesn't go as fast. Particles move faster in hot water as opposed to cold water. When we take a look at this, when we look at stirring in something like salt, which is a really good solute, I'm going to use hot and cold water. The particles of this salt are actually kind of chunky, special kind of coarse salt, and I'm going to pour about the same amount into both deals. So here's the thing, is that guys, when we stir, eventually everything will come out and all of those particles will dissolve. Right now you can't see it, but I can still see chunks at the bottom. If I look at the hot one, all of the chunks have actually gone into tiny amounts of powder. And I can actually stir that powder much easier into my water. I'm now finished dissolving all of the salt. If you look into the cold one here, there's still some on the bottom, so I still have a ways to go. And I think I'll be stirring here for a little bit more time because cold water does not dissolve solutes as fast as hot water does. That's one of the factors affecting solubility, and I'm not even finished. There's still chunks of salt on the bottom. So cold water takes a lot longer to dissolve things than hot water does, and that's super important. So that's the deal, you guys. We need to know that there's 3 things that mainly affect the factors affecting the solubility. How much of that powder can we get into the liquid? And so you need to remember that it's the type of solvent, so the types of liquids that you're using, the type of solute, remembering that the types of powders that you use sometimes don't dissolve as good, and the temperature. Those are all things that affect how much or how good the solubility is of a substance. I want you guys to remember the particle model of matter, and we've already looked at it today. Just remember that all matter is made up of tiny particles, super important, that the particles are always moving, and that when you add heat, the particles move faster. There is one more thing that we need to talk about today, and it's affecting the rate, which is the speed of how things dissolve. We've already seen it today, and the first thing is the temperature. I already showed you how fast hot water dissolves stuff, and so we already know that temperature is one of the main things that affects the speed. The second thing that affects speed, which we haven't really looked at today, is the size of particles. I have been using some coarse salt. However, if I was to put one huge big sugar cube into the water, it's actually going to take a lot longer for me to break the sugar cube down and get it to dissolve. It's kind of like eating one of those really big jawbreakers. It takes a long time. Size of particles, big, huge chunks of things take a long time to dissolve, whereas tiny particles usually take a small amount of time, except in the case of baking soda, because baking soda doesn't like water. But normally the smaller the particle, the easier it is to get it to dissolve. And so I can dissolve these smaller chunked up pieces of salt a lot faster than I can dissolve this big thing of sugar, which I have to break up with my stick. So size of particles affects the speed. The very last thing that affects speed is stirring. And so we've already seen that. The more you stir, the faster things get dissolved. So you need to remember 3 things that affect the speed of solubility are temperature, hot's always faster, are the size of particles, small is always better, and the last one is stirring. More stirring is better. That's all you need to know for today. Thanks for joining me. Hope you have a great week.